the physician's reactions case study, the probability value associated with the significance test is 0.0057. Therefore, the null hypothesis was rejected, and it was concluded that physicians intend to spend less time with obese patients. Despite the low probability value, it is possible that the null hypothesis of no true difference between obese and average weight patients is true, and that the large difference between sample means occurred by chance. If this is the case, then the conclusion that physicians intend to spend less time with obese patients is an error. This type of error is called a type 1 error. More generally, a type 1 error occurs when a significance test results in the rejection of a true null hypothesis. By one convention, if the probability value is below 0.05, then the null hypothesis is rejected. Another convention, although slightly less common, is to reject the null hypothesis if the probability value is below 0.01. The threshold for rejecting the null hypothesis is called the alpha level, or simply alpha. It is also called the significance level. As discussed in the introduction to hypothesis testing, it is better to interpret the probability value as an indication of the weight of evidence against the null hypothesis than as part of a decision rule for making a reject or do not reject decision. Therefore, keep in mind that rejecting the null hypothesis is not an all-or-nothing decision. The type 1 error rate is affected by the alpha level. The lower the alpha level, the lower the type 1 error rate. It might seem that alpha is the probability of a type 1 error. However, this is not correct. Instead, alpha is the probability of a type 1 error given that the null hypothesis is true. If the null hypothesis is false, then it is impossible to make a type 1 error. The second type of error that can be made in significance testing is failing to reject a false null hypothesis. This kind of error is called a type 2 error. Unlike a type 1 error, a type 2 error is not really an error. When a statistical test is not significant, it means that the data do not provide strong evidence that the null hypothesis is false. Lack of significance does not support the conclusion that the null hypothesis is true. Therefore, a researcher would not make the mistake of incorrectly concluding that the null hypothesis is true when a statistical test was not significant. Instead, the researcher would consider the test inconclusive. Contrast this with a type 1 error in which the researcher erroneously concludes that the null hypothesis is false when in fact it is true. A type 2 error can only occur if the null hypothesis is false. If the null hypothesis is false, then the probability of a type 2 error is called beta. The probability of correctly rejecting a false null hypothesis equals 1 minus beta and is called power. Power is covered in detail in another chapter.